Hello. In this video, we will cover the run modes in GPX using the GPX library project. To open this project, go to the dashboard view and click on the icon next to select to open an existing project. In this case, I already have the GPX library project opened, as you can see on the right-hand side of the GUI where it displays the project name, and also you can see that all the views are enabled. Before we do our exercise, we will save a copy of this project. To do so, click on the icon next to Save As and leave the copy selected from the Save As dropdown. We will name this project GPX Library Copy. You can click on Browse to select where to save this project, and I will save this on my desktop. I'll create a new folder and call it Library Copy. And then you can click on Select Folder. After doing that, click on Save to save a copy of this project. A pop-up message will appear asking you to make sure that any changes that have been made in the current project have been saved. And you can click Yes on this message. An information message will appear in the Messages Center, letting you know that the GPX library was successfully copied to GPX Library Copy. Click Done to clear the message. We will now move through the views to see the data that has already been entered in this project. Moving to the Observed Data view, we see that 3 different types of exposure data entries have been already created, as well as solubility data has already been created for some of the compounds in this project. Moving to the compounds view, we see that there are 9 different compounds in this project. You can review the physicochemical properties of any of these compounds by clicking on it and then opening panels to analyze the properties of the compound. We'll skip over to the simulations view. And from the simulations dropdown, we can see that there are 9 different simulations created in this project. Instead of running each simulation individually, we will run a batch simulation using the run mode in GPX. We will select the brick dust simulation from the simulation dropdown. In the drug administration panel, we can see the dose number, the dissolution number, and the absorption number. And we can see that both dose number and dissolution number are red, while the absorption number is green. And this suggests that the solubility might be a limiting factor for absorption. We will click on Check Warnings and then Run Simulation. Next, we will navigate to the absorption and dissolution plot in the Key View ribbon. By default, all available mass versus time curves for the absorption and dissolution plot are displayed. We will open the plot settings panel by clicking on the plus sign located at the top of the bar to display the legend. We will uncheck the systemic circulation mass entered curve as well as the total portal vein curve. And for this, we can hover over the plot name to see the entire name. And we see that the first one is the systemic circulation, which is the green curve, and we'll deselect that one. And if we hover over the blue curve, we'll see that's the total portal vein. Deselect that one as well, and we're left with the dissolution curve, which is the red curve, and the absorption curve, which is the purple curve. And from this, you can see that from looking at the dissolution curve, which is the red curve, in 24 hours, the total dose of brick dust was not completely dissolved. And we can also see that the purple line, which is the absorption line, diverges only slightly from the dissolution curve, and that indicates that the absorption of brick dust is primarily solubility limited. We can now move on to the summary view from the mode dropdown to see that the predicted fraction absorbed for brick dust is just over 55%. And this means that only about 55% of the compound is absorbed from the GI tract in 24 hours. A parameter sensitivity analysis can help to determine the degree to which permeability, solubility, and dissolution limit the absorption of this drug, and therefore know how we can improve the fraction absorbed. We will now navigate to the Runs view and select the Add drop-down menu, and from this drop-down, we will select the parameter sensitivity analysis. We will name our run Brick Dust PSA, and then click OK. You can see that the run is added to the run list, and the list of available simulations to be included in the run will be enabled. We will click on the Include toggle next to the Brick Dust 10 mg PO tablet simulation name. In the simulation setting panel, we will leave the analysis mode as sequential, and we'll leave also the simulation baseline toggle on. We'll now scroll down to the parameter selection list, from which you can select which parameters you wish to vary for the PSA. In this tutorial, we will select the median particle size, solubility, tablet strength, and permeability. And for this, we will use the search box to find these variables. First, type median and hit enter. Now click on the checkbox next to the median. Next, we will clear the search box and type solub, S-O-L-U-B, and we will select the solubility under the reference solubility entry. Next, we will select permeability by clearing the search box and then typing perm, and then hitting enter. We will select the box next to human under the source permeability series. And finally, we will select the tablet strength. And for this, you can type STRE and then hit enter and select the strength, the tablet strength. You will see that all these parameters have now been added to the list on the right-hand side, and we will leave the lower and upper bound as well as the baseline values as is. Scroll down to the Run Controls panel and click Start. The sensitivity view mode, as you can see here, is automatically selected for the PSA run. And once the run is completed, the analysis view will automatically appear in the GUI. On the left-hand side of the blank plot, you will find the compounds drop-down list, which is the list of all the compounds that are in the simulation used for the PSA. In this tutorial, we had a single compound, which is brick dust. A results list from which you can select which parameters you wish to assess is also displayed. And finally, you can also see the input parameter list, which is a list of all input parameters selected for the PSA run. From the results list, we will select the fraction absorbed. And from the input parameter list, we will select all the input parameters that we have created. And for this, you can simply click on the first parameter, and holding Control on your keyboard, you can select all the other parameters. This output indicates that within the range of values tested, the percent absorbed is extremely sensitive to the green curve, and as well as to the red curve. If we expand the plot legend and hover over and click on the green curve and hover over its name, we will see that that curve relates to the solubility curve. We can now select the red curve and hover over its name to see that that particular parameter is the particle size. So we see that the absorption of brick dust appears to be primarily limited by solubility and dissolution rate, which is related to the particle size. On the very left-hand side, there is a list of all simulations that were ran during this PSA. You can expand this panel by dragging it over. And each simulation is named with each parameter value that was varied. For example, here, the particle size that was varied while holding all the other parameters constant at their baseline value. We will now switch the mode to key view. And in here, we will select the CP time plot. And here you can see the CP time profile for each of these simulations. You can click across the key view ribbon to see all other plots. And of course, these plots are going to be very busy because you have a lot of simulations plotted at the same time. We will now select the simulation that had the highest Cmax for its name to be highlighted in the plot legend. And when we hover over this curve with the highest CMAC on the graph, we see that the legend is selected here, and hovering over, we can see the full name. And we can see that that simulation is related to having the particle size as 4 micron. If you'd like to do a more in-depth analysis of this particular simulation, you can do this by unselecting all of the other simulations by clicking once in the brick test and then clicking on it another time, and then selecting the simulation of interest. You can now go through the different plots in the key view ribbon, as well as do more in-depth analysis in the deep view mode in GPX. We will now reselect everything by clicking on the square next to the brick test once again. And we will switch the mode to summary view. We will drag this across so we can see better, and we won't select the observed data toggle. Now we can compare all the simulated results between all the simulations that were run during this PSA. If you wish to sort the simulations by, for example, fraction absorbed, you can do so by holding Alt in your keyboard and then clicking on the column header. And once again, we can see that the simulation that had the highest fraction absorbed was 4 micron simulation. You can continue to do further analysis with the other parameters by clicking on Alt and then clicking on the column header.